This is section 4.2, solving equations of the form x squared plus bx plus c equals 0 by factoring. Your I can statements is I can solve quadratic equations. Monomial is an expression that is either a number, a variable, or a product of a number and one or more variables with whole number exponents. So an example of a monomial just means it has one term. So 9 would be a monomial. X squared would be a monomial. 4x cubed y squared would also be a monomial. There is only one term, there's no addition or subtraction. A binomial is the sum of two monomials. So we could say x squared plus 5. And a trinomial is the sum of three monomials. So x squared plus 4x minus 7 would be a trinomial because there are three terms. So we will be factoring some trinomials. The rules for factoring trinomials. A trinomial is in the form of x squared plus bx plus c equals 0. We're going to find the values that multiply together to give us the value of c, that add together to give us the value of b. Now, if both signs are positive, then when we're factoring, both of your signs will be positive. If c is positive, it means the signs will be the same, and then the sign in front of b will tell you if both are going to be positive or both are going to be negative. If c is negative, it means you're going to have one of each sign. There will be one positive term and one negative term. So we need to factor the expression x squared minus 9x plus 20. When we do this, we're going to have two sets of parentheses. Now, because this is positive, we know the signs are going to be the same, because a positive times a positive will give us a positive, or a negative times a negative will give us a positive. Since this is a negative, we do know both signs will be negative. Now, to help you figure out what terms can multiply, we can see what multiplies to give us 20 that adds to give us negative 9. So multiplies to give us 20 is 1 and 20, 2 and 10, or 4 and 5. Now we do know that both signs have to be negative, and we want to see which two will add up to give us that negative 9. So we have a negative 4 and a negative 5. We also want to see what's going to multiply to give us x squared, which in this case will just be x and x. So this is the factored form of our expression. If we factor this one, because this is negative, we know we will have one of each sign. We want to know what multiplies to give us x squared, and so that's going to give us x and x. Now we want to know what multiplies to give us a negative 12. That's going to add to give us 4. So multiplies to give us negative 12. We have 1 and 12, 2 and 6, or 3 and 4. Now we do know that one side is going to be positive and the other side is going to be negative. But since it's going to be a positive when we're done adding, we do know the larger numbers are going to have to be positive. So our smaller numbers would have to be negative. Now we're looking for the combination that'll add to give us 4, which is going to be negative 2 and 6. So we have a positive 6 and a negative 2. Now there are special factoring patterns. If you have a difference of two squares, and it does have to be a difference, it has to be subtraction, then when we factor, we'll just get a plus b times a minus b. So if I have x squared minus 4, I can take the square root of x squared, I can take the square root of 4, and it is a difference problem. So the square root of x squared is x and x. The square root of 4 is 2 and 2, and you will have one positive and one negative. Now we also have some that are going to be a squared plus 2ab plus b squared. And if you factor that, you're just going to end up with a plus b squared. We can do the same thing if it's a minus 2b. So if I take the square root of this, a square root of x squared is x. the square root of 9 is 3. And 2 times a, our a value is x, so 2 times x times 3 does give us 6x. So when we factor this, it will be x plus 3 squared. We can do the same thing if it is subtraction. Now, if we notice, this is just a binomial. It just has 2 pieces, but I can take the square of this piece, I can take the square of this piece, and it is a difference, so we can factor these. Now remember, it's only going to work if it is a difference. If it's a sum, then we cannot factor these. Now the square root of x squared is x and x. The square root of 49 is 7, and we're going to have one positive, and we're going to have one negative. Now on this, if I take the square root of this, I'm going to get x. If I take the square root of this, I'm going to get 6. And 2 times 6 times x does give us 12x. This is plus, so this is going to be x plus 6 squared. Now, the good news is, if you don't remember that rule, you can still just factor this like normal. So we do have our 2 sets of parentheses. This is positive. We know they're going to be the same. Since this is positive, they are both going to be plus. Multiplies to give us x squared is x and x. And then we want to see what multiplies to get 36, that adds to get 12. So we could do 1 and 36, 2 and 18, 3 and 12, 4 and 9, or 6 and 6. And to add up to give us 12, it would be this 6 and 6. And since both of these monomials are exactly the same, we could write it as x plus 6 squared. So even if you don't remember that special rule, you can still end up with the exact same answer. Again, we can take the square root of x squared and get x. The square root of 169 is 13, and 2 times 13 is 26 times x gives us 26x. Because this is subtraction, we can write this as x minus 13 squared because of the special rules. Or if you don't remember the special rules, you can always factor this like normal. So because this is negative, you do know the signs are going to be the same. Since this is positive, we do know the signs are going to be the same. Since this is negative, we do know both signs will be negative. Multiplies to get x squared is x and x. And then we're going to break down the factors of 169 to add to give us 26. So we have 1 and 169. And we do have 13 and 13. Adds to give us 26, so it has to be 13 and 13. Since these are the same, it would be x minus 13 squared, which is the same answer we got when we used the special rules. Now, this is a quadratic equation if we have ax squared plus bx plus c equals 0. So if it's written in this form, it is a quadratic equation. The roots of the equation are the solutions of the quadratic equation. Zeros are the values of the variable that allow a function to equal 0. Now, the roots of an equation and the zeros of the equation are actually the exact same thing. It's just different terminology depending on the situation the problem is in. So what are the roots of the equation? To solve this, you first have to make sure it is equal to 0. If it's not equal to 0, you will need to take everything to the other side first. Then we are going to factor like normal. We want to see this is negative. Multiplies to get a negative. 1 has to be a positive. 1 has to be a negative. Multiplies to get x squared is going to be x and x. And we are looking for what multiplies to get 36, adds to get a negative 5. So I could do 1 and 36, 2 and 18, 3 and 12, 4 and 9, or 6 and 6. Now we do know that 1's positive and 1 is negative. And since when you add, you end up with a negative number, it must be the larger numbers that are negative. So if we pick the pair that's going to add up to give us negative 5, it would be a positive 4 and a negative 9. Now to find our roots, we're just going to take each of these pieces and we're going to set them equal to 0. Remember, to get the x by itself, we're just going to do the opposite. So on this one, since it's a positive 4, we would subtract 4 from both sides. And since this is a negative 9, we would add 9 to both sides. And we'll be left with x is equal to negative 4 and x is equal to 9. Those would be the two roots of our equation. We're going to find the zeros of the function by rewriting the function in intercept form. So again, the zeros and the roots are the same thing. We're just going to rewrite this. So if we factor this to write this in the intercept form, multiplies to get a negative. The only way to do that is to have one positive and one negative. Multiplies to get x squared is x and x. We want to see what multiplies to get a negative 12 that adds to get a negative 1. So multiplies to get a negative 12 is 1 and 12, 2 and 6, or 3 and 4. Since we're adding and getting a negative number, the larger number must have been negative. And if we're looking for the combination that when we add together we get a negative 1, we have a positive 3 and a negative 4. Now this is in intercept form, but we want to find the zeros. So again, we're going to do x plus 3 is equal to 0, or x minus 4 is equal to 0. If we subtract 3 from both sides, we're going to get x is equal to negative 3, and if we add 4 to both sides, we are going to get that x is equal to 4. Find the zeros of the function by rewriting the function in intercept form once again. So if we write this in intercept form, multiplies to get a positive, so we know the signs are the same. And since this is a positive, we do know that both signs will be a positive. Multiplies to get 36 and adds to get 12. So 36 and 12. Now, if you can find these factors without having to write these out, that is perfectly fine. Or you can write these out to find them. But if you can automatically say what multiplies to get 36 that adds to get 12, we know it's 6 and 6, you can go ahead and write that down. Remember, this also was a special case, so we could have written this in this form. But to find our zeros, to get the x by itself, we are going to subtract 6 from both sides, and we are going to get x is equal to negative 6 for both of them, so we actually only have to write it once.